to the third of the Professional Development Network Rewind. Today we have Nicole Fever. Hi, Nicole.
Hi.
Nicole works for Steve Vick, and Nicole entered the Northern Branch Norman Howell competition this year. And due to the current circumstances, we held our presentation competition virtually this year. I said I wasn't going to mention these in precedent times, but there's a difference to how we usually run it and how most of the other branches have run it. So Nicole presented this at our regional final and was our runner-up. So if you've got any questions throughout this talk from Nicole, if you could put them in the chat box, and we will get round to asking Nicole. Without further ado, Nicole, I'll pass over to you.
Thank you. The annular Endseal system, an innovative solution for annular pipe sealing. Steve Vick International in partnership with Southern Gas Networks. Presented to you by Nicole Fever. Southern Gas Networks, SGN, approached Steve Vick International, SVI, to design and develop a method of permanently sealing the open annular space between Tier 1 metallic pipe and inserted polyethylene pipe. As you can see with the help of the red arrows, the annular space between the polyethylene pipe and the metallic pipe in Figure 1. The first question you may ask is, why seal the ends? The seal is required to prevent the ingress of water and backfill material, which can lead to road surface slumping. The seal will also prevent the potential tracking of gas through the old annular space, which can lead to expensive and time-consuming leak investigations. The scope for this project was to design and develop a sealing system which could be used by SGN main-laying operatives after a small amount of training. Initially, the system would be designed to work in conjunction with SGN's I-core excavation system, but not limited to this. The system should be able to function properly in cleanly cut cast iron pipes and pipes with rigid or broken ends. Figure 2 is an I-core excavation with the use of a long-handled tool. Figure 3 is a standard gas replacement. The final product will fill the annular spaces of the following sizes: 75 mm polyethylene pipe within 4-inch metallic pipe, 125 and 6, 140 and 8, and 180 and 8. Figure 4A shows our baseline product. Foam Pack is a sealant already approved within the gas industry. This product is a sealed unit with a disposable spine that separates two chemicals. Once the spine is removed and the chemicals are mixed, it is then inserted into a cartridge where it bursts during injection. The mixture will expand into a closed-cell foam that meets GIS LC14 2009 specifications for a gap annular sealant. During the baseline tests, I tested the tensile strength of the outer seals on the foam pack sachet and replicated this on our sonic weld machine. Through further testing, I found a suitable setting that could create a burst seal. By using the burst seal, we are replacing the one-use plastic, aka the spine, on the current foam pack. As you can see in Figure 4B, we have the outer packaging, Part A resin, the temperature gauge, the two-part spine, the protective sleeving, and within, Part B hardener. Figure 5 and 6 are the sonic weld machine I mentioned earlier, and Figure 7 was the testing of the burst seal. The first round of testing that I carried out did not use any chemicals. Instead, I used water. I added food coloring into one side and then proceeded to add pressure to one side of the sachet and eventually force the middle burst seal to open. And with the help of the red coloring, I could check for imperfections and holes that the sonic weld machine might have left. On screen now will be a demonstration of that experiment. For manufacture and production in the future, we already have started discussions with sachet manufacturers. Using these weld settings, I then started volume testing to decide the quantity needed to successfully seal each individual annular space. As there is a fine line between what would fit in the very small annular space and the quantity of foam needed to create the sufficient seal, a great deal of testing and redesign was needed to arrive at the optimum solution. Once SGN representatives witnessed the designs most suitable for each pipe size, field trials were discussed. While the field trial locations and communications were dealt with on SGN's end, I continued testing and perfecting the designs. As you can see it on screen now, figure 8 to 13. Product requirements that needed to be taken into consideration at this stage. The sachet needed to fit into the annular space, not being too bulky or oversized. The sachet must hold 2 chemicals of a specific volume separately until needed. Once the chemicals are fixed, the exit point opens because of the pressure the foam creates as it expands. Through testing, I found a plethora of information that later influenced the final design, such as the rectangular shape made the central burst seal more difficult to open because of an increase of surface area. The shorter the burst line, the easier it is to burst. Having the same shape on both sides of the sachet makes it easier to mix. Figure 15 is a photo of myself demonstrating an early design for the SGN representatives. Figure 16, I am demonstrating on-site the use of an annular sealing bag for the first time. Figure 17 was the very first burst seal tested with water. And figure 18 is a final design of an annular sealing sachet with wooden dowels. You are now going to watch a short clip about how the annular sealing sachet is used. Squeezing one end, you can open the first seal in the middle of the sachet. You then mix the 2 chemicals until they are a consistent color. In this experiment, I'm going to use a long reach tool and therefore insert the sachet using 2 metal prongs. I will then lower the sachet into my artificial excavation and insert the sachet into the annular space. The field trial stage. The manufacture of handmade annular Endseal sachets included manually weighing out each chemical, filling both sides of the sachet, and sealing the ends. After I wipe them down, I carry out a visual inspection for leaks or imperfections. If they pass the visual inspection stage, then the sachets are ready for packaging. I then box the sachets, including correct labels, information, instructions, and PPE. This is a very time-consuming manufacture process that I carry out for each field trial. And if the field trials were given at a very short notice, I would then have to put in hours of overtime to get them ready. I personally supported site with an SGN representative multiple times. This included traveling to Scotland to demonstrate and train 2 separate main laying teams. I then supported them as they carried out field trials collecting images and feedback. Each size is trialed at least 12 times, 6 inserted by hand and 6 inserted using a long-reach tool. This was carried out over multiple sites and days over the time span of approximately 6 months. All feedback that had been witnessed, written, or verbally given had been incredibly positive. The product can be mixed and inserted within 1 minute, and the annular seal will be established, even without the main layers having to be there. We advise a 30-minute reaction, expansion, and cure time before a visual inspection, and then the trench can be filled as per usual practice. Figure 19, I am demonstrating the burst pouch on site for the first time to one of the main laying teams. Figure 20 and 23 are main layers inserting an annular sealing bag by hand. Figure 21 is a main layer inserting the sachet onto a long-handled tool. Figure 22 shows the sachet being inserted using the long-handled tool. And Figure 24 is a visual inspection of the seal after the foam has expanded in the annular space. Thank you for listening. For further information after this webinar today, please visit stevick.com.
Thank you, Nicole. Thanks for a very good presentation, and thank you for doing this virtually with us today. Got a few questions that have been sent through. One from Ash, who's sharing his screen for us. What benefits did you get out of compiling this presentation of your own work, and would you recommend taking part in a presentation like this to others?
I would highly recommend being, in a situation where you are happy to present. It's such a great experience, and it's great for my future in the industry, just being able to present and accumulate all my work. Because, I mean, at the end of a project, you don't really realize how much work you've put into it. So having to compile the appropriate words for this presentation, I realized how much effort I've put into it. And I'm really very proud of the presentation and the product, and my company has been incredibly positive about my development, because I started as an apprentice doing this project and now I'm fully qualified. So I'm very proud to be able to present this to everyone today, and I highly recommend anyone to try their hand at a presentation or just a competition in general, just to see how it goes.
Brilliant. No, I totally agree with that, and it's nice to have something at the end of the project to kind of look back on and see what you've done. I had a quick question as well about the uptake and the on-site field trials you were doing. How did that go down with the main layers?
So the main layers were very standoffish to like the very beginning. Once you communicate with them in like just normal chit chat, and then you sort of explain the situation and be very forgiving to the fact that they have a job to do and you are taking valuable time out of their day, and you try and be as efficient and as kind as you possibly can. And once I demonstrated the sachet for the first time, they were very positive. They were like, oh, this is going to be easy. Okay, what do you need us to do so that we can get on with our job and you can get on with yours? So it was incredibly positive.
Good. And then we've just had 2 questions going. One from David Mitchell. How does the foam get out of the packet once inserted? How do you ensure the foam gets under the slit line pipe at the bottom of the hose pipe? So
the first question was, how does it exit the sachet? So as you saw in one of the many videos, the middle of the sachet has a burst, and you do that by hand. You mix it, and then once you've inserted it, so it's a decent color, you insert it into the annular space on the crown of the pipe. That's very important. There's also a burst seal at the end of the sachet, further that you've inserted into the pipe. So once the foam starts to expand, it then bursts the seal by itself. So it's just under pressure, it expands and bursts itself. And the foam is very good at it. It's very liquid to begin with, and then it expands and lifts and ingresses into the debris in the pipe and everything to make that perfect seal. So
Okay,
that's,
brilliant. So,
I think that's that question.
So David then followed that up with, is there an application in the water industry, or have you considered that?
I can say that we haven't tested in the water industry, but we do have foam suitable for the water industry, and we have done products in the past. So I can't see any problem with an inquiry coming in and our company just trying to understand the circumstances that he might need this. So if he is inserting and it's the annular space, I can see this product with a different foam, because this foam reacts as a catalyst with water. It would have to be a different foam. But with different quantities and test work, we could definitely find something suitable for him.
Good. And then Luke Spencer's asked, does it achieve a full circumference gas tight seal? Yeah.
Yes. So it's a closed cell foam, and with a gas tight seal, you do only a visual inspection. So, I mean, the testing in my lab, I've tested it against 3 to 6 bar. Like, I'm very happy with the tightness test of it, but obviously on site with a pipe inside, it's very difficult to test the final seal. So I can say in the lab, yes. Perfect circumstances, yes, it makes a perfect seal.
Good. Another question from Tony Voss. Apologise that you missed the first few minutes, but does the sachet that you use, does that get left in situ? Does that stay within the excavation? Does that cause any issues with the pipe wall?
So the sachet itself gets covered in foam. So it stays in situ, and the seal is 300 ml in front of the sachet after it's been inserted. But on a good occasion where this pipe is flat and not in an incline, so if the sachet is placed on the top, the foam will go forward more than it will go back. So generically, you put it in, and the sachet will have a 300 ml seal in front of it, and then you'll also see some of the foam come back along the sides. So that's how you see your visual inspection. But yes, the sachet stays inside the pipe in the annular space.
Okay, and that won't cause any poor sealing issues within the annulus?
No.
Okay, and finally we've got a question from Richard Swan. Does the resin cure better when water is present, as I could see water in the bottom of the trench? So
we had to do a visual inspection prior to inserting the sachet, and we prefer no water ingress, but a small amount is fine, because our hardener does have a water as a catalyst for our foam, so it could make the foam expand at an unstable amount. So although the trench was dug underneath the pipe and there was water sitting inside the trench, inside the annular space it was dry, so it was a suitable situation.
Brilliant. Well, thank you, Nicole. That's the end of the questions that I've got on in the chat. Thank you very much, Nicole. And just a quick one from me. We've got a few events, a few more webinars this week. On the 16th, we've got pipeline rehabilitation. And on Friday, we've got the Pint of Pipelines pub quiz hosted by the Guild HQ. So it'd be good to see you all there. Thank you all again, and speak to you soon.
Yeah. Thank you for having me.
Thanks, Nicole.
Bye.